this video, record this lecture so that I can post it on Blackboard in case if someone missed it. And also I must say that, the university is not subscribed to Zoom. So this meeting will end in like approximately 40 minutes. So please log back in to continue the class. Please log back in. I will give you a reminder, like, I get a reminder at 10 minutes or so. So I will ask you to log back in. And you can stay mute. And then whenever I ask a question or so, please, you can respond. And also I have the chat box available. You can continuously send me chat or like text messages to that. And also direct it to me, not to the class. Now, these are the equations that we learned in the last class. The first equation I have in two forms. The first one is when you have a constant acceleration. The second one down here, when you have an acceleration that is changing with time. And then the next equation, that is, we usually call it the second equation. This is for the displacement. And then the last equation is as follows. We have V final square equals to V initial square plus 2A delta X. Now, guys, if you look at the very first equation over here, you can see that these equations do not have any information about displacement. So if someone is looking for displacement, then this equation is not the first equation to try. And then the second equation down here, you can see that this does not have the final velocity component. So if you are looking for the final velocity, this equation should not be the first to look at. And then lastly, we have the equation without the time component. However, you can use these equations more than once. In some cases, you will have to use the equations more than once. And there I cannot say which equation to use first. Sometimes you can use the first equation to find the time and then use it in the second equation to find the displacement. So there are some times like that as well. Now we discussed a few questions in the last class, and I want to discuss one special problem from chapter 1 before we get into a vertical motion. Vertical motion is very similar to this, but there are a couple of things that we need to pay attention there. But before we get there, I like to discuss problem number 70. So I will give you a couple of minutes to read the problem, or if you want to take a screenshot, go for that. This is not the same textbook, textbook version that I have posted online on Blackboard, but this problem is there. May not, because I don't have the same textbook version at home. So let's read this carefully and get the notes. Two particles move along an x-axis. The position of particle 1 is given by x equals to 6t square plus 3t plus 2 in meters and seconds. The acceleration of particle 2 is given by a equals to negative 8t in meters per second squared and seconds. And at t equals to 0, its velocity is 20 meters per second. When the velocities of the particles match, what is their velocity? So as I said, you have to summarize this. have particle 1 on one side and write down all the information given for the particle 1. Then get to particle 2 and write down all the information given under particle 2. And then we can look at the final velocity. As it says, the final velocity for both are equal. And the question asks us, when that happens, what is the velocity or what is the magnitude of that velocity? As I said, if you have any questions, the chat box is down there, and direct the message to me, not to the class. So if you have taken down the notes, I'm going to remove this and then write down the notes on my book, on the page. You guys need any time? If you do, either raise your hand or just unmute and say you do need more time. Okay, so I'm going to take it away and then write down the information. Let me just lift it up so that you can see the thing. There you go. All right, so particle 1, this is problem number 70 from my version of the book. Maybe it's not the same of what is posted on Blackboard. But anyway, particle 1 on this side. And the other side, particle 2. Particle 1 has x. The displacement is given as a function of time, 6t square plus 3t plus 2. Particle 2 has a couple of things given to us. A equals to negative 8t. Initial velocity, v initial, is given as 20 meter per second. And then it says final velocity for this one, Vf, and final velocity of this guy, the same, I'm going to call it Vf. Now, how do we approach a problem like this? If any answers, if you have any ideas, you can just, unmute and talk. Particle 1 doesn't have a lot of information. It only has the displacement and it is given as a function of time. Now, let's say that I want to find the particle 1's velocity at time equals to 0. What should I be doing? How can you find the velocity if the displacement is given?
The displacement function.
Which, are you talking about this equation?
I was saying for particle 1, the displacement equation, if you find the derivative of it, it'll give you the
Right.
velocity
Absolutely.
equation.
Absolutely. Thank you. So there you have particle 1 displacement given. So in order to find the velocity, you can take the derivative of the displacement function, which is 12t plus 3. Right? Take the derivative of the displacement function, 6t square plus 3t. 6 is out, the 2 comes out, which is 12, and 12t. And there you have 3t, that's 3. The constant does not give us anything. So the velocity is given to us as 12t plus 3. Now, if you want to find the initial velocity, what do we do? Initially, what is the value of time? What do we do?
Set t equals 0.
Absolutely. To find the initial velocity, let's set t equals to 0. So you get V initial equals 12 times 0 plus 3, and that would be 3 meter per second. So you have initial velocity. Now we want to find the acceleration. How do we find the acceleration? I'm waiting. We have a displacement function, we have velocity function. How do we find the acceleration? I can see people talking, but I don't hear anything.
Do you take the derivative of velocity?
Absolutely. Yep. You take the derivative of the velocity to find the acceleration. So A equals dv by dt. And what is that? 12. 12t plus 3. Take the derivative of that, and that gives us 12. Now that we have the initial velocity and the acceleration, we can find, or we can write an expression for final velocity. That would be our first equation, and V final equals V initial plus AT. I picked the very first equation because clearly the acceleration here is a constant. 12. No t is in there. So I write V final equals V initial is 3, A is 12, and there you have T. There's nothing else I can do here, and I call this equation equation number 1. If you guys have any questions, please do ask. And I am actually recording the video, recording the lecture anyways. So this is what I have. Now this is particle 1. Now I am looking at particle 2. Particle 2 has a variable acceleration and initial velocity. Now what do I do there? Which equation do I pick to find the final velocity? I can show you the equations one more time. These are the equations. Which one do I pick if I have the initial velocity and a variable acceleration?
The first equation.
First equation, but which form? First form or the second form?
The first form.
Well, if you pick the first form, then the acceleration has to be a constant, right? But here I have an acceleration as a function of time. The answer is correct. We have to use the first equation, but we cannot use the first form of that. We will have to use the one with the integration. All right, so let's do that. We will write V final equals V initial plus integration A dt going from 0 to t. So there you have V final. Initial velocity is 20 plus the acceleration 8t and dt going from 0 to t. So you pull out the negative 8. I am doing that because I have a couple of students who have not seen integrations yet. That's why other students, you can immediately write the final answer. So there you have 20 minus 8 t square over 2. So there you have V final equals 20 minus 4t square. And that's all we can do there. And this is the equation number 2. This is for particle number 2. Now have a look. V final for the first particle is 3 plus 12t. V final for the second particle is 20 minus 4t square. Now let me share the problem again. Here goes the problem in case if someone did not take the screenshot. When the velocities of the particles match, what is their velocity? That is the question. In other words, the equation 1 and equation 2 should be equal to each other because that's when the velocities match, right? So I am going to take another paper here. And then I set equation number 1 equal to equation number 2. So there you have 3 plus 12t on this side, and the other side we have 20 minus 4t square. And I take all the t terms to one side and rearrange this equation. So you have 4t square plus 12t plus 3 minus 20 equals to 0. And again, simplifying this, 4t square plus 12t minus 17 equals to 0. So we have a quadratic equation. In a quadratic equation, we need to solve for t. Now I am going to write an equation. Perhaps you will remember a quadratic equation from your previous classes. Ax square plus bx plus c type. Remember that? Guys? Ax square plus bx plus c equals to 0. And how did you find x? Minus b plus or minus b square minus 4ac divided by 2a. If not, you guys have your TI-89 calculator. Feed the equation and ask it to solve for time. We know one thing, time cannot be negative. We know one thing, time cannot be negative. So pick the positive answer for time. So what we are doing is we are looking for the time when the velocities match. Once you find that time, you can substitute it in one of the equations and find the velocity, and that's what the problem asks. Now, the reason that I am doing this slowly and on record is because, you should expect something like this on the exam. It's a calculus-based class, and here I am involving both derivatives and integrations. So in my equation here, I'm looking at this, the coefficient of the square function is 4, and the linear term b is 12, and c is minus 17. And someone can do the work using a calculator. I don't have a calculator in front of me, and send me the answer on the chat. You should get 2 roots. Most probably one of them will be negative. Okay, I have one answer. Let me open the chat. Another answer. They both actually are the same. Yeah. Third answer came in and they are almost the same. Yeah. As I said, the TI-89 knows how to do the solving using the solving function. You can do that. Did you guys get the negative function as well? If you have negative value for the time, you are sending me only the positive value. Send me the negative value as well. Those who are sending me 1.05 and 1.049. Do you guys have the second root? Yeah. Oh, thank you guys. Yeah. All right. So I am getting these answers. P1 equals to 1.05 seconds or 1.0495. I'm just taking the second up to the second decimal. And the T2 is negative 4.049 seconds. Now these are the roots that we get when we solve the quadratic equation. And then we pick this value because time cannot be negative. With the 1.05, with T1 or time equals to 1.05, we can use equation number 1 to find the final velocity. Equation number 1, we have final velocity equals 3 plus 12 times 1.05, and someone sent me that answer as well. Final velocity is, what is it? 15.594 or 15.59, something like that. V final equals 3 plus 12t. That's what the question has. That is our first equation. So when you plug the numbers in, 12 times 1.05. What is it? What is 12 times 1.05? And then you have V final is about 15.6 meter per second. And this is the final answer to that question. So the problem involves quite a bit of algebra, and then the derivatives and also the integrations. Since I am recording this, I am not going to go back to the beginning, but this is what we have. We wrote down a summary about the particle 1 and particle 2. And then we looked at the displacement function, found the velocity function, found the acceleration. And based on that, using the kinematic equations we have, we derived an equation for the final velocity for particle number 1. Particle number 2 has a variable acceleration by initial velocity given to us. And you can find V final. And then there you have V final equals to 20 minus 40 square. Now, why did I use equation 1 and not 2? No preference. You can use the equation number 2 as well. And you should end up with the same answer. You should end up with the same answer. So there's no preference because equation 1 equals to equation 2. Once you find the time, you can substitute it in any equation. So in 7 minutes, this will stop and you guys will have to come back, okay? So this is the rest of the work that I did. I set the two equations equal to each other because the problem says that the final velocities are equal. And there you have a quadratic equation set up. And then this is the general form. And this is how you do it without a calculator. And these are the two roots. One is positive, the other one is negative. We ignored the negative one because time cannot be negative. And we went with the first one. I mean the positive and value for the time, and I picked the first equation and ended up with 15.6. So as I said, you can pick either equations, 1 or 2. Any questions? Either you have to say yes, you have a question, or you have to say no, then I can move on. Now, do you guys think that if I include a problem like this in the exam, it's fair? Those who say it's fair to include a problem like this, then give me a thumbs up. Because this is a calc-based class, right? Alrighty. All right, so I'm going to move on now, and I am going to share the screen where I have the vertical motion. Now, when we get into vertical motion, we are not just doing vertical motion. First couple of questions will be simply vertical motion, but later on, we will combine both vertical and horizontal motions together and do a couple of problems. Now, in the vertical motion, well, here you can see a person at a cliff and dropping a ball or dropping an object. Now, as you can see, well, you don't know this, but I do. The pictures are taken in each second at equal time intervals. Now, you can see at the beginning, the motion is kind of slow. And then later on, you can see that the displacement between consecutive time intervals is increasing. The displacement is increasing. This kind of a motion tells us that this is accelerating. The object is accelerating. And the most important thing here is that we have an acceleration, a non-acceleration when it is dropped or when it is moving under the influence of gravity. We have an acceleration equals to 9.8 meter per second square. That is something you have to know, that the acceleration is 9.8 meter per second square under the influence of gravity. That is what is called as the gravitational acceleration. Magnitude of the acceleration is 9.8 meter per second square. Now, this is a place many students who have taken physics before do mistakes. Acceleration is a vector. Acceleration is a vector. If you take up as your positive direction, please pay attention, guys. If you take up as your positive direction, with respect to that direction, the gravitational acceleration is negative 9.8. Negative 9.8 meter per second square. If you take down as your positive direction, then of course you will have a positive 9.8 meter per second square as your gravitational acceleration. But please know, I am going to take up as my positive direction. I am going to take up as my positive direction. So now and the next couple of chapters where I discuss projectile motion, I will stick to this. So please put a big star next to this and draw this arrow pointing this direction up as the positive direction, and write down the gravitational acceleration, if you want to call it a sub g, that's fine, equals to negative 9.8 meter per second square. Even when you are doing, let's say that you do a mistake, and by a mistake you take it as a positive 9.8, then that will completely destroy your final answer. You can't flip it. I will always take up as my positive direction and down as my negative direction. And when I say so, let me quickly stop the video here, stop sharing here. So here I have my worksheet. Now this is what I mean. Like I take, this is my coordinate system. This is the 0. Here is my y-axis, positive y, positive direction. And this way, this is my negative direction. So I always take this plus as my positive direction. And with respect to the direction I pick as positive, I always take a sub g. You don't have to write the sub g, but I'm writing it anyways. Just to indicate the gravitational acceleration. There you have a sub g equals to negative 9.8 meter per second square. Whatever happens below this point, they are all negatives. If you have a displacement below the line, that is a negative displacement. If a velocity is pointed in the downward direction, that is a negative velocity. And what are the equations that we are going to use in order to solve problems here? I think this is going to stop now, and I will restart. And then we can discuss the next part. You guys can come back.